Welcome to Global Virtual School. Students, this is your first year chemistry class. I am Dr. Izad Banu, and the topic for today's discussion from chapter 3 is bond energy and the relationship between bond energy and polarity of the molecules. Students, after completing this topic, you will be able to describe the change in bond length. Bond length basically is related to the bond energy of the heteronuclear molecules due to difference of electronegativity values of the bonded atoms. How electronegativity difference between bonded atoms change the bond energy of the molecules, and you will also be able to explain what is meant by the term ionic character of a covalent bond. We will explain this with the help of example and solving with actual values of the bonded atoms. So this bond energy or bond enthalpy. Bond energy and bond enthalpy are the same things. Enthalpy means just heat or energy. Whenever a bond is formed, energy is released. Whenever a bond is broken, energy is required. So these are like exothermic and endothermic processes. But how to actually define bond energy? It is the amount of energy required to break all bonds of particular type in 1 mole of the substance. Usually we take the bond energy for 1 mole of the substance. So 1 mole of substance that contains all of the bonds, the energy required to break all those bonds in 1 mole of substance, that is called the bond energy or bond enthalpy of the substance of that molecule. Whenever a bond is formed between two atoms, energy is released, and this process is exothermic process, because exothermic are the process in which heat or energy is released, heat or energy is emitted, while whenever the bond is broken between two bonded atoms, energy is absorbed. Energy absorbed means energy is required, energy is taken by the system. So this is the endothermic process. So bond formation is exothermic process and bond broken is the endothermic process. And the bond energy can be defined for 1 mole of a substance is that the energy enthalpy change, energy change in splitting. Splitting means to separate, to break a molecule into its component atoms is called enthalpy of atomization. For example, you have H2 molecule. The energy required to break these are for 1 mole of hydrogen gas or hydrogen molecules into their particular atoms like hydrogen and hydrogen, or like you have HCl. The energy required to break for 1 mole of HCl to convert them into hydrogen atom and chlorine atom. Similarly, if you have like S8 molecule, the energy required for 1 mole of acid to convert them in a single sulfur atoms, that energy is called the energy of or enthalpy or bond energy of the atomization. And it is the energy required to break 1 mole mean 1 mole is the Avogadro's number, that is 6.022 10 raised by 23 atoms or bonds of a substance, and its units are usually joules and kilojoules per mole. So usually the values are written for 1 mole of the substance and they are determined in joule or kilojoule of the substance for the energy. And the bond energy usually it depends upon the strength of the bond. Higher the bond energy means the bond is more stronger. If energy is lower, it means the bond is weaker. Bond energy is determined experimentally by measuring the heat involved in a chemical reaction. So experimentally, this is bond energy is calculated by observing the heat change that is involved during a chemical reaction, and for that purpose calorimeters are used to calculate the enthalpy of the bond. And the bond energy is measured at 25 degree, that is the standard temperature, or 298 Kelvin. 298 Kelvin means 25. If it is in Kelvin, you have to write 298. If it is in Celsius, 25. So if we measure this at above or low temperature, then the bond energies values will be changed. So the standard temperature at which the enthalpy is measured, that is the 25 and 298 Kelvin, and the energies of the multiple bonds are greater than the single bond, means Single bond energy is less as compared to double bond. Double bond energy is less as compared to triple bond. And the polar covalent bond is stronger than a non-polar covalent bond. It means a non-polar covalent bond, it has low bond energy, and a polar covalent bond, it has a higher bond energy. And the bond energy, like we have the examples of hydrogen H2HH. So 1 mole of hydrogen, it requires 436 kilojoule per mole at 25 R298 Kelvin. So this is the standard bond energy for the hydrogen. So standard bond energy for the chlorine Cl2 ClCl. So for 1 mole of chlorine bonds, energy required is 242 kilojoule at 298 Kelvin. Similarly for HCl, 1 mole of HCl, it requires 431 kilojoule to break at 298 Kelvin or 25 Celsius. And students, bond energy, what is the relation between bond energy and ionic character? Basically, its ionic character depends upon the electronegativity, size of the bonded atom, bond length, and the bond order. Bond order means either this is a single bond, double, or triple bond. So we have the example how the bond energy is related to the electronegativity. Here is the fluorine is the most electronegative element of the periodic table, that has the 4, and hydrogen has 2.1 electronegativity value. Chlorine has lesser than fluorine, that is 3.5. Bromine's electronegativity is even lesser than chlorine, and iodine has the least among these halogens like fluorine, chlorine, bromine, and iodine, while hydrogen in this case is the same for all the halogens. So let's see what is the bond energy of HF. 566. HCl is 531. For HBr it is 366, and for hydrogen iodide it is 298. So bond energy is decreasing. Why? Because of decreasing difference of electronegativity. HF has the maximum difference of electronegativity, so it has the highest bond energy. HI has the least electronegative difference, so it has the low bond energy. So it means HF has higher ionic character and higher bond energy. So basically one criteria is difference of electronegativity. So hopefully this will be clear for you. More of the electronegative difference, more of the bond energy, and lesser the electronegative difference between two bonded atoms, this bond energy reduces. And how it depends upon the size of the bonded atoms and the bond length and bond order. I have a table for you. For example, we have this bond, and Be stands for bond energy. I have written this Be. Be means bond energy. You have this example, carbon hydrogen bond, carbon carbon, carbon nitrogen. You know the size of hydrogen is lesser as compared to carbon. Carbon size is lesser as compared to nitrogen. As their size increases, their bond energy decreases, because by increasing size their bond strength is weaker. Bond strength is weaker, it means their bond energy is lower. Like CH has 413, while CC has 348, and CN has 298. You can also observe with reference to this example, HF, HCl, HBr. Although this is for you can quote this example with difference of electronegativity, but as long as fluorine also is lower in size as compared to chlorine, chlorine is lower in size than bromine, bromine is in lower size than iodine. So as the size increases, that if fluorine has this size, then chlorine has this size, bromine has even more than this size, and iodine has even more than size. So as the size increases, their bond energy decreases, because due to change in size the bond is weaker, and their ionic strength also decreases. That's why their bond energy decreases. Let's come to the multiple bonds. Now we have the example carbon-carbon. They are the homonuclear molecules. Again carbon-carbon, but this is single bond, and with this is double bond. This carbon-carbon with triple bond, and you can see a triple bond has the highest bond energy among their carbon bonds. Double bond is greater than single bond because triple bond carbon is more strong and more energy is required to break this bond, and carbon double bond it has lesser as compared to triple bond, but its bond energy is greater as compared to single carbon. Similarly, you can observe in this, if nitrogen and nitrogen they have double bond, its bond energy is 480, but if it has triple bond is even stronger than double bond, it has even higher energy, that is 495. Similarly, some other examples are given here. So bond energy also depends upon the bond length, or you can say the bond order of the molecules. So what is the relationship between bond energy and polarity? The relationship is simple. Polar molecules have greater bond energy as compared to non-polar. And polar, polar bonds are formed between two atoms that have greater difference of electronegativity, and non-polar they have lesser or zero difference of electronegativity. And due to increasing difference on electronegativity, their ionic character increases. And this I already these features, like polar bonds are stronger than non-polar, greater amount of energy is required to break polar bonds, and due to ionic character strength of bond increases. And we have discussed this in previous slide that stronger is the bond, higher is the bond energy. Similarly, polar or covalent bonds are stronger than non-polar covalent bonds, and multiple bonds have greater than single bond. But now we are just discussing in this we're taking the example to observe polar bond, and in polar their ionic strength. So how to calculate the ionic strength? This will be observed with the help of this example. Let's concentrate and focus on this example, what it is going to calculate. So increase in strength of HCl bond. HCl is a stronger bond as compared to H bond. Our ionic character, you can say, in HCl bond can be observed from the experimentally. Now we will determine the bond energy of HCl experiment theoretically, and also the experimentally given. Then we will compare their difference of energy. Now come to the first step is calculation of bond energy contribution of one hydrogen atom. You will observe this from the H2 molecules that has a one bond. So I already quoted the example. Bond energy of H2 molecule is 436 kilojoule per mole. Remember, this is for 1 mole of bonds, and 1 mole means 6.02 10 raised by 23 bonds. And how much will be for one bond? This is for 1 mole of the bonds, and now we have to calculate for one bond, only single bond, not a 1 mole, only a single bond. So this will be divided by Avogadro's number, and you will observe this is 72.42 10 raised by 20 minus 23 kilojoule per 1 bond. Remember, this is for 1 mole. For 36 is for 1 mole. 1 mole means 6 point. This energy is for 6.02 10 raised by 23 bonds. And for 1 bond, this is 72.42 10 raised by minus 23. So how will be this? This is for 1 bond, and we have to check the contribution from single hydrogen. So this will be divided by 2, because this molecule contains only 2 hydrogen atoms. So this will be divided by 2, and now we got this value 36.21.23 kilojoule per 1 bond of 1 atom, 1 hydrogen atom. Remember this. Now this is for 1 hydrogen atom. Similarly, calculate for chlorine. Chlorine Cl2 molecules. For 1 bond, for 1 mole of bonds, it's 242. 1 mole means this 242 kilojoule is for 1 mole, 6.02 10 to the 23 bonds. and we have to calculate first for one only single bond. So this will be divided similarly by Avogadro's number, and you got the answer 40.19 10 raised power minus 23. This is the kilojoule per one bond of chlorine. This is for single bond. And the contribution for one chlorine will come by dividing this 2, and this is the value. This is 20.09 10 raised per minus 23 kilojoule per one bond of single chlorine atom. This one. So now what will be the for HCl bond? These two will be added from hydrogen contribution and from chlorine contribution. So third step is calculation of bond energy of 1 mole of HCl. First will be calculated for one bond and then for 1 mole. That is total bond energy of one HCl bond will be bond energy of hydrogen atom and bond energy of chlorine atom. So you have these values. It comes 56.3 10 raised power minus 23 kilojoule per one bond. Here one bond of HCl, single bond of HCl. So for 1 mole it will be multiplied by Avogadro's number 6.02 10 raised power 23. So we got 338.93. So this is the theoretically calculated, and what is the observed? Observed is 431.1 kilojoule per mole. While calculated is lesser, it means the HCl bond is stable and it has some ionic character. That's why experimentally determined value is greater as compared to theoretically calculated. As this difference increases, their bond energy increases. So its stability of HCl bond is due to presence of ionic character. It has some ionic character and some covalent character. So due to presence of ionic character is present and bond energy increases due to difference of electronegativity between two bonded atoms, and as this difference of electronegativity increases, greater the ionic character and stronger will be the bond. Now we have this example. You can even, we have calculated for this. X means fullerene. Here X means fullerene. This X means chlorine. So this is fullerene. So this fullerene, or you can say fullerene. Its bond energy is 152, and this is for chlorine bond energy, and this is for bromine bond energy, and this is for iodine. And you know, in previous for chlorine that was 242 kilojoule per mole, and X means here will be for fullerene and here will be for chlorine. So this is 293 is for HF, and 338 as just we calculated, this is for HCl, and this is for HBr, and this is for HI. And the observed that is calculated from experiment for HF is and HCl, just we have observed in previous slide, that is 431, and the difference between them is 95. Now if you move back, the difference is greater. 274, it means more ionic character, so it is even stronger. Its bond energy will be greater, like this is 567. And if this difference of energy, electronegativity difference is lesser, then the difference will be lower and bond energy will be lesser, 366. And when HI, the difference of electronegativity is even more less, so very less ionic character and bond energy is even very reduced as compared to fullerene or chlorine, that is 299. So as the difference of electronegativity increases, their ionic character increases and their bond energy increases. So electronegativity difference is related to the ionic character, and ionic character is related to the bond energy. So this was all about the ionic character, mean their polarity. So this was all about the bond energy and its relationship with the polarity of the molecules. And our next topic will be bond length and dipole moment.